Okay, this is the proof of Theorem 6, which is the quotient of two complex numbers. The theorem says that z1 divided by z2 is r1 over r2 times the cosine of theta 1 minus theta 2 plus I sine theta 1 minus theta 2. So again, we have to define z1 and z2 in terms of polar complex numbers. r1 cosine theta 1 plus I sine theta 1 is z1, and z2 is r2 cosine theta 2 plus I sine theta 2. And so then we plug it into the formula. But we should notice that this is a complex number, and rules of math say we do not like complex numbers in the denominator. If we multiply by the conjugate, which means the opposite sign, then that will drop out. But if we do it to the bottom, we have to do it to the top. So we multiply top and bottom by the conjugate of the denominator. Foiling both the numerator and the denominator out, you see that you get cosine theta 1 times cosine theta 2, cosine theta 1 minus cosine theta 1 times I sine theta 2, plus I sine theta 1 times the cosine of theta 2, minus, because we have a plus times a minus, I squared, I times I, sine theta 1 times sine theta 2. That's the numerator. When we FOIL out the bottom, cosine theta 2 times cosine theta 2 is cosine theta 2 squared. Cosine theta 2 times a minus I sine theta 2 is minus I cosine theta 2 sine theta 2. I sine theta 2 times cosine theta 2 is I cosine theta 2 times the sine of theta 2. And I minus I times I is minus I squared, and then sine theta 2 times sine theta 2, or sine theta 2 squared. Now these drop out because they're the same angle. And I'm going to go ahead and rearrange up here. I'm going to bring this minus I squared sine theta 1 sine theta 2 with the cosine theta 1 cosine theta 2. And I'm going to rearrange these two terms so that I have my terms with the I in them together. Now, when I do this, when I cancel this out, I have minus I squared in the denominator. But I squared is negative 1, so minus a negative 1 is plus. That's where that becomes a plus sign. Simplifying up here, minus I squared is also plus here, and we factored out an I here. Now, from trig, we should remember that the cosine squared of theta 2 plus the sine squared of theta 2, or cosine squared theta plus sine squared theta, is equal to 1. That's our popular trig identity. However, this piece right here is the difference formula for cosine, and this right here is the difference formula for sine. So we can rewrite this as r1 over r2 times cosine of theta 1 minus theta 2 plus I sine theta 1 minus theta 2, which is what we were trying to prove. So therefore, our theorem is true.